I was going to say boys and girls, but I'll just say boys. Good afternoon. Come on, we are not in the online world, right? This is the real world, where we're talking to each other. Good afternoon. Wow, much better. Thank you. So, welcome to analyze billions of rows of data in real time using Azure Data Explorer. I'm Niels Berglund. I'm software architect lead. Sounds fancy, it's not. Software architect lead at Derivco. We're an online gaming company based out of Durban, sunny Durban, South Africa. Whoa, yes, absolutely. And if we have offices all over the world. I'm not saying you should apply, but we have offices all over the world. So if you're interested, cool. And I'm also a Microsoft Data Platform MVP. Before we go any further, session feedback, right? When I go to conferences, session feedback, that's not important. It is very important, because if you give feedback on sessions, etc., the organizers can make a much better conference, right? So that is one reason. The second reason is that the more feedback SQL bits get in, the more will they donate to National Trust. They're donating saplings or something to do some stuff, right? So that's the second reason. It is important. It is good because SQL bits will donate to National Trust. And the third thing, selfish as we are, you can win prizes. You can win awesome prizes. Actually, I don't know what the prizes are, but people are telling me they are awesome. So you can win prizes. So I did a one-day class on Tuesday about Azure Data Explorer. Actually. And on the Wednesday, I saw on LinkedIn a picture of a post from SQL Bits showing a picture of a prize winner after having submitted session feedback. So yes, it is real. You can win prizes. Cool. So the link to the left is where you can give feedback on this particular session. And the right-hand side there, that code, I'm not very technical, but yeah, that's you know what to do with it, right? I always goes for the links, so that's cool. Anyway, so Azure Data Explorer, data in the name. So we'll start with talking about data in general, and lead into why we need Azure Data Explorer. We'll then talk about Azure Data Explorer, get an overview. We'll look at ingestion. How do we get data? So it's cool to have this thing, Azure Data Explorer, right? But how do we get data into it? Then we will finish off by seeing how we are querying data in Azure Data Explorer. So, out of you in the room here, how many are SQL Server users? Very strange seeing that this is a SQL Bits conference, right? I hadn't expected that. Actually, so cool. How many are using Azure Data Explorer in anger? Whoa, a couple of guys. I can't get away with lying too much then. Bummer. How many have no idea what Azure Data Explorer is? Isn't that new File Explorer in Windows 13? Okay, so you can, most of you have somewhat of an idea. That's cool. Right. Before we drill in, so I'm an old guy. I remember David Letterman. I don't know if you guys in the room remember David Letterman. He was a US talk show host. I think he's still alive. I have no idea. I think he's still alive. He had, his shows, he had his list, the top number of reasons for something. So thinking, coming to SQL Bits, I'm gonna put down my top 5 reasons to come to SQL Bits. There is a method in the madness here. You will see that in a second. So the number 5, the number 5 in my top list, to learn new things. That's what you tell your boss. That's what you tell your spouses. Hey, I want to go to SQL Bits because they will learn awesome stuff. And I will be able to give so much more value back to the company when I have been in SQL Bits, right? That's kind of what we are saying to our bosses. That's reason number 5, and that's a valid reason. Reason number 4, get to hear interesting stuff. It may not be related to what you're working with, it not be related to your job, but you get to hear cool stuff, sorry. Whoa. See, that's what happens when I'm saying bad words, right? So you will get to hear interesting stuff. Reason number 3, now it's getting warmer here. Reason number 3, get away from home. I don't know about you, but God, it's good to be away at a conference, being face to face after a 2-year lockdown, right? It's good. Reason number 2 now is really hotting up. It's to hang out with your brethren, kind of goes with number 3, meeting people. Meeting people that you knew before COVID. Meeting people that you've never met face to face before, but you met them online. That's awesome. And then, the reason number 1 why you come to SQL Bits or to conferences in general is to get swag. I mean, admit it, we are like children in a candy store when we're coming to a conference like this. Ooh, I can get stuff here. Ooh, how cool is that? And then you come home to your mates, to your spouses, to whatever, and say, look at this cool t-shirt I got. Free. Then that you paid quite a lot of money to attend the conference is neither here nor there. The t-shirt was free. So, this is where I'm coming. So I'm very much of interactive guy. I need communication, discussion. So I have swag. I have awesome t-shirts here. A couple. Given to me by my employer, Derivco. And I have notebooks, right, with accompanying pens. How cool is that? And so normally I say I give, you get swag if you're asking good questions. Right now I'm saying you will get swag if you're asking bad questions. Actually, you will get swag if you're asking a question, period. Right? So remember that. Questions means swag. Are we good? Awesome. All right, so data. Megan Trainor, that kind of shows my music taste, I don't know. Megan Trainor, pop singer, I hope someone has heard about her, otherwise this kind of falls flat. Megan Trainor back in 2014 had a song, It's All About the Bass. I will not try to sing it, but she was wrong. It's not all about the bass, it's all about the data. And when we are looking at data landscape in the world, we are generating more and more and more data. So in 2020, it was estimated, I have no idea how people estimate this, but it was estimated that we had 44 zettabytes worth of data. 1 zettabyte is a trillion, billion, whatever terabytes. It's a lot. Right? 2025, we are estimating 175 zettabytes of data. That's a lot, so that's kind of a huge increase, which may be neither here nor there. The problem with this is that while we are growing with 400%, less than 30% gets analyzed. So now, you, me, we are hoarding data because someone has told us that at a conference like this, having data is good. Push your data into the data lake. That's good. And we're doing that and we're feeling awesome, right? We are with the technology. We are pushing data into the data lake. But what do we do with the data? Maybe nothing. Then the data is just a cost center. It doesn't give us anything. So where I'm going with this is that we have lots and lots of data, but we need to analyze that. And that's where Azure Data Explorer comes into the picture as one system of many that helps us with this whole analyzing data. Yeah? So speaking then of data, big data and modern business, if we're having if we're looking at the graph, something like this, where we on the x-axis are looking at the data complexity, the velocity, and the variety, the three of the V's, right? And on the y-axis we have data volumes. Back in the day, a couple of years ago, well, a little bit more, we had ERP CRM systems, fairly much relational data. They weren't too complex. It was, as I said, relational structures most of the time. Megabytes, gigabytes worth of data. The velocity and the variety was not that wide. It was not that big because it was fairly structured data. Then we came into the Web 2 world, where we now started with advertising, e-commerce, stuff like this. All of a sudden, the data volumes grew, and also the variety and the velocity that the data comes into your systems grew. And now we're at a phase, the big data phase, where we have all these various producers of data, and we are coming into volumes in the petabytes in our organizations. The variety is wide. The data is complex. The velocity is huge. Right? Thousands, 10,000 events per second being pushed in. And the type of data here is it's a lot of free text data, i.e. it's not structured. And it's a lot of append only. So back in the day, back in the old days, when I was a little bit younger than I am now, I mean, we ingested data into SQL Server, and then we updated data in SQL Server. I will still do that, obviously, but now a lot of the data that we see here is being just appended. We're just shipping it into somewhere in huge volumes. And we also have a lot more decision makers of the data, or at least a lot more people that want to see the data, to see analysis of the data. Back in the day, you had a team, BI team of 4, 5, 6, 10 people creating reports, running batch jobs, and they gave these reports to the C-suite, and the execs were looking at it or not looking at it. Now, there's a lot more people that want to see your reports. More users want to see the reports, and we are talking, now it's popular to talk about user-facing analysis. And we want to do real-time decisions based upon the data. So it's no longer good enough to run a batch job once a day and the next day give the report to the execs. That's not good enough. And this user-facing analysis is kind of interesting in that on the left-hand side, we're seeing from LinkedIn who has viewed my profile. Yeah, I know, I'm not that popular. Anyway, so, but the idea here is that this graph is fairly up to date. It is kind of at least, well, maybe not per second, but it's at least per minute up to date. And if we think about LinkedIn and the number of users that at the same time can click this, who has viewed my profile. Think about the systems that underlies this, that can support this kind of stuff. We need to have systems that helps with this. And on the right-hand side, seeing something that is kind of near and dear to my heart, it's this a leaderboard, right? Where it's some sort of a game, and whatever thing the players are doing here, they are scoring, they are getting a score, and then they're coming up on a leaderboard. And now we have hundreds, we have thousands of players that want to see where are they on the leaderboard. And they want that now, like that. I mean, batch job is not good enough. Hey, you will see it tomorrow. Not going to work. All right? So this is examples of user-facing analysis. Anyway, I'm rambling. Azure Data Explorer. So what is Azure Data Explorer is here to help with some of these problems. Right? So Azure Data Explorer is a fully managed big data analytics platform, i.e. it runs on, as the name implies, it runs on Azure. And you do not do anything with it. It is managed by the Azure team. Right? It's high performance, and it analyzes high volumes of data in almost real time. So let's have a look at that high performance thing. So here we go. So for you that have used, well, for you that have used or haven't used Azure Data Explorer before, but you have used SQL Server, so when we are in Management Studio or Azure Data Studio, if we want to switch between databases and stuff, what do? Someone answer me. What is the statement we do? We do not click on the left-hand side, right? What statement do we do? Use database. Yes, the gentleman wins a prize. It wasn't a question, but he answered something. That's also good. So, and initially, so this is now the equivalent of Azure Data Studio or SQL Management Studio for Azure Data Explorer. Right? It is web-based, which has its, yeah, it's here and there. Anyway, normally, before I heard about this, I don't know if it's a trick or everyone knew it, but beside me, so what you needed to do to change databases here was to click on your individual databases, and then the scope changed. Take note of this. This is worth the entry fee for this conference. Hash, connect, cluster, cluster name, database, database name. That is the same as use database in SSMS. Maybe you knew that. If you knew, good on you. If you didn't know it, you're welcome. Cool. Anyway, so what was I saying? Yes, performance. Yes, sir.
What scripting language is that now that you're interfacing with?
Say again?
What scripting language is that you're now interfacing?
What scripting language that is? Can someone answer the question, what scripting language is that?
I don't guess. That's not KQL, right?
So that is KQL, a cluster query language. We'll talk, yeah.
Is it KQL? Okay.
Yeah. Cool. We'll talk more about that in a second. Anyway, so performance. Kind of lost track here what I'm doing. So, no, you're welcome. So here we have a table in the GitHub data. So in GitHub, when we are doing stuff in GitHub, events are being generated. Whatever you do, an event is being generated. What Microsoft has done, it has captured events from GitHub, because they seem to have some interest in GitHub, right? So they have captured events in GitHub, and they have loaded that into a database here in Azure Data Explorer in a publicly available cluster. And if we're looking at, if we're saying, so GitHub event take 10, can you guys in the back see? Well, if I take that as a yes. So if we're running take 10, that's like you select top 10 from GitHub table, or whatever that table is named. And here we see now we have an ID column, a type column, an actor column, etc., etc., etc. If we're looking at the actor column, that is an JSON blob. So in Azure Data Explorer, a table can have your normal suspects when it comes to data types, int strings, what have you. It can also have a data type called dynamic, which means that you can more or less send in everything, anything you're interested in, you can send into that data type, into that column. So here we now have a JSON blob in that column. And I can do cool things with this. Well, I can do things with this JSON blob, such as trying to come on. I can say, give me, from the actor column, give me the display login name. Right? So I'm drilling down in the JSON blob, and I'm looking for display login, a field, right? An element, whatever you call it. And when I run that, so I'm getting now down here, we will see 10 different logins coming in. Nothing very strange with that. What I then can do is now I want to know how many, I want a count of all the distinct logins in this table, right? Yeah? So many people have logged in more than once, obviously. I just want them, well, you know what distinct means. So if I run that, please work. And when we look at that, that took 4.8 seconds, almost 5 seconds. I don't know if that is good or bad. But remember, we parsed JSON. We parsed and looked for a specific field. If we then look at how many entries do we have in, how many records do we have in this table? That, my friends, that is 1.2 billion records. So we parsed 1.2 billion records, grabbed and did a count. They did a distinct count in less than 5 seconds. That's quite good performance. Yeah? Cool. So that was just to show that, yeah, maybe there is something when they say that Azure Data Explorer has performance. Anyway, and we can analyze high volumes of data in near real time. We have an end-to-end solution for data ingestion. We will talk about ingestion in a second. We can ingest in many, many ways, right? And we can query, we can visualize, etc. Data Explorer is good for, well, log analytics. If you are using Sentinel or Microsoft Defender or App Insight, if you are querying those logs, you are using KQL to query those logs. Azure Data Explorer is excellent for IoT scenarios and general events in general, right? So we can work with almost any kind of data. Structured, that's fine. Semi-structured is fine. We have support for various well, types, JSON, Parquet, all the usual suspects when it comes to that, built into Azure Data Explorer. We can automatically ingest, process, and export. We have KQL. When you get used to it, it's a fairly user-friendly language when you kind of see how it hangs together. So it's a little bit like if you've written link statements in C#, for example, where you start the statement with the source, i.e. the table name. So instead of doing select star from table, you're doing table, well, table star or what have you. And you're piping commands together. We have advanced analytics, so we have built-in time series analysis, we have built-in machine learning, we have built-in anomaly. Well, as we have time series, we can also do anomaly detection, etc. Cool, and we can visualize the data. Anyway, so the architecture. Questions so far?
I don't need more swag. I just wanted to find out what are the similarities and difference between Synapse Data Explorer and Azure Data Explorer? Is it sort of the same technology, one in a unified solution and one as a standalone?
Awesome question. What's the Well, what is Azure Data Explorer versus Synapse Data Explorer? It is it is the same thing almost. See Azure Data Explorer as the standalone version. And so they started with Azure Data Explorer, or Custo, as it was also called. They started with that, and then they saw that in Synapse, we need now a way to do similar things to what we can do in Azure Data Explorer, but baked into Synapse. So they released Synapse Data Explorer. So it is the same thing, kind of. Where you in Azure Data Explorer, you are setting up your cluster, etc. In Synapse, you don't. You're having server pools, but yeah, so it's the same thing.
Thank you.
Wait. I can't hear a word.
Will it work with anything other than Azure storage accounts? So, for example, AWS S3 account.
Will it work with anything? Will it work with other storage account than Azure? The answer, well, the short answer is no, because we'll talk about this in a second. The storage is highly optimized, proprietary, highly optimized. But you can work with other storage because you have the notion of external tables. But I wouldn't use that. I would use external tables for kind of reference data or something like that. Can you ship that back to the gentleman that asked the question? So does that make sense? Whoa, cool. Right, so, yes, sir.
So one more question. Your example there had billions of rows in it. At what point, I know it's a little bit, you can answer it depends if you want, but at what point, like if I've got 10 million rows, is there a cut-off point for like size-wise, or is this like for the massive billions of rows? If I've got, because we actually have a situation where we've got maybe 100 million things with JSON coming in pretty quick, and your query in JSON there would be like, oh, that's great, because we're having to do it by SQL at the moment, which is not the best, but I'm kind of thinking, is this enterprise scale and we're not quite there, or are there like rules or limits on size?
Okay, so where are the limits? I guess is the question. How much data can I push in here, and
also what's like the cost? Because obviously this isn't free. It's like me, if I'm my VM, it's no point in being a hyperscaled VM because I'm not going to get any use out of it. Sort of thing.
So at least for the first question, I'm not going into the cost thing. So for the first question, I mean, it is vertically scalable. So I do not know. Honestly, I don't know if there is an upper limit or not. But yeah. So think about this: that this is not your SQL Server where you're sitting on one box. Yeah. This is a distributed storage under the covers. That is so more. So the VMs. So okay, let me come back to that. So we have a cluster, right? In the cluster, we have a cluster can have one or more nodes. In the cluster, we have one or more databases, and the databases has one or more tables. You have the ability to create functions, and you can create materialized views. A cluster, a cluster can have maximum of 10,000 databases, and each database can have a maximum of 10,000 tables. These, you can always have then more cluster if you go over that, right? Because the clusters can talk to each other. The Azure Data Explorer runs on VMs, right? And when you're setting it up, you decide how many do you want to start with, and then it can auto-scale. And all of this goes down into a storage account. So you're getting a storage account created for you. unfortunately, I've tried, unfortunately, you can't drill down into that storage account. You can't see what's in it because it's, well, it's proprietary. And the nodes, the individual VMs, also have high-performance SSD disks being used for caching of data. So you have the notion of hot cache, and you're having the notion of, well, of warm data. Say again?
Is it going to interconnect with the Delta Lake layer for your normal Azure storage blob?
Okay, so can you connect to Delta or data, or well, Data Lake or Delta? Yes, you can, but once again, that would be through that would either be to ingest data into Data Explorer, or treat the Delta as external tables. Right? Whoa, okay, cool. Anywho, so as I said, 10,000 databases, 10,000 tables. Here is the cool stuff. I think it's cool. So when we have a table, right? In SQL Server, we're storing the data in pages. In Azure Data Explorer, we're storing data in shards, or because shards is being used in other places, Microsoft decided to call them extents. So we have, each node has its own extent that it stores down into the storage account. And when you are ingesting data into the Data Explorer, a new extent is always created. So is that good? Yes, it is good, because you are not you are not competing with the data that is already there. So the data comes into an extent at one stage or another. The extent will be merged into the other or others extent. But for each new blob of data that you are sending in, a new extent is created. And then at one stage or another, there is a process in Azure Data Explorer that are merging the extents. Cool. Yeah, you don't care about indexes. Everything is indexed for you. You don't care about foreign key constraints. They are overrated anyway, right? You need to have, if you're having those sort of requirements, then you need to code for it. Cool. Yes, sir?
If I understand correctly, the shards can also be read by multiple nodes concurrently.
So that's a very good comment, question, whatever. The shards can be read by multiple nodes concurrently. And so if I am ingesting data, and I am almost at the same time reading data, my read will hit that new shard, that new extent. But yeah. Cool. We have two main services in ADX. We have the engine service and the data management service. The engine service is the service that eventually handles ingestion of data and also querying of data. Right? But data is being ingested through the data management service. I can ingest data straight into the engine service, but that is not advisable, at least not in a production environment. Right? So when we are normally in production, when we are ingesting data, we are doing it through the data management service. Essentially, you don't really care about that. When you are setting up a cluster, you're getting two endpoints. You're getting a query endpoint and you're getting an ingestion endpoint. And You are querying against the query endpoint, strangely enough, and you are ingesting through the ingestion endpoint. And that's all you need to worry about. So the architecture looks something like this, that we have the data management service, we have the engine service. The engine service talks to the SSD, and the engine service also talks down to the blob, to the Azure storage. If we want to compare this to SQL, I tend to go back to what I somewhat know. Then the engine service is kind of like your SQL Server instance, i.e., it handles persistence of data, and it has databases, etc., etc. Right? But don't go and say to people that Niels said that SQL Server is the same as the engine service. Because that's not the case, but that's how I kind of look at it. So how do I ingest? Right, we are ingesting from various places. So we're having SDKs, Python.NET, Java, etc. We have managed pipelines, so I can do direct ingestion from event hubs into Azure Data Explorer. We can do ingestion from connectors. So for example, I can connect from Kafka, one of my favorites, Logstash, etc. And then we have some tools that allows us to do ingestion, like what they call the one-click thing. One-click is very cool. It's very cool. It's a cool tool because that looks at your source data and can create the sort of the schema in the database for you. So if you look at that. Say again?
Sorry, one-click, is that through Azure Data Factory?
No. So the question was, is one-click through Azure Data Factory? No, but however, well, I'm lying. You can do one-click ingestion from Azure Data Factory here through one-click, but one-click doesn't use Azure Data Factory. So here, I'm in the UI, and one of the UIs for Azure Data Explorer called Data Explorer. Yeah. So you get to that through dataexplorerazure.com. Anyway, here I have, if you see on the left-hand side, I'm having a data button. This data button allows me to do one-click ingestion. And we can see here that we have a lot of different sources, a lot of different ways we can do one-click ingestion. And here I want to do it through my local file. So I'm clicking ingest. I'm choosing the cluster that I want to ingest into. I'm choosing my database. I want to create a new table that I'm saying is called TB_retail. So that is that's kind of the target. Then I'm saying from file. Select up to 10 files. Let's see if I can find them, because this was not prepped in any shape or form. Ingestion data. There we go. Cool. So now we are uploading here the file. This will take a while, maybe not. Anyway, so I can now ingest through one click, and then I have a table created. I have everything created for me. We'll come back to this when it will, at one stage or another, it will be done. Right. Questions so far? Okay. Cool. We have 10 minutes to go. Right. somehow I think that we will not see that ingestion. Anyway, so we are ingesting into the cluster. When we are ingesting, we need a table unless we're having one click creating the table for us. We can set a retention policy. How long do we want the data to stay in this table, or how long do we want the data to be in the extents? And as we said before, we have so many variety of data. We need to tell the table what the data looks like. All right. So we're doing what we call an ingestion mapping, saying that this field in the block, well, this field here matches this column, etc., etc. So here's an example where we are having a table called gameplay. We are setting up a JSON mapping because we will get in JSON blobs. And we are saying that we have a column in the JSON blob we have a column in the table called player ID, and in the JSON blob we have a field called player ID, etc., etc. Right? And we're creating that, and life is good. And we can decide whether we want to do streaming ingestion or batching ingestion, where batching is for high throughput. So if you have large amounts of data, batching ingestion is good. And the best practices is to use, so here we're talking about if you're having, well, if you are ingesting 1,000 events per second, then you can easily do streaming. But if you have more data than that, then it's better to use batching and have the batches in sizes between 100 meg up to a gig that you are ingesting. Streaming ingestion as well is ongoing. Think that you're ingesting from Event Hub, from Kafka, what have you. So we are querying using KQL, custom query language. It's somewhat similar to SQL, other than that we are starting with the source, and then we are piping commands into. So command data is flowing in like a funnel. So we're starting at source, we're having maybe a where command followed by some other command, etc., and eventually we're coming to the end. By default, we are getting full text indexing. We also have support for time series analysis, as I said. We have some built-in machine learning features, mostly segmentation based. We also have support for R and Python. So if you remember back in SQL Server 2016, Microsoft introduced the notion of external languages, where we had support for R. In 2017, Python was introduced, and in 2019, Java was introduced, which means that we can execute R, Python, well, in SQL Server, we can execute R, Python, Java, and actually C# as well in SQL Server, but it executes outside of SQL Server. The same thing goes here for Azure Data Explorer, where you can execute R code and Python code in Azure Data Explorer, and it executes in a sandbox outside of Azure Data Explorer. So some query samples here to finish this off. So GitHub event, we saw that count. We are doing some visualization. So in the client, or rather in the web UIs, you have support for visualization by the render keyword. We have seen how we're parsing JSON on the right-hand side top, and then on the lower side, we're doing some linear regression calculations. And I mean, all that built into ADX, all this built into the custom query language. Yes, sir? Does render real time?
Yeah.
It.
You see a child moving in the
Okay. No. So the question is, does this render real time? So what the rendering is doing, wow, is like a snapshot, as it looks now. And the rendering is there more for you to visualize. This is not good. I can tell you that. Come on. God. So the other thing, I don't know if you boys and girls are doing any conferences, presentations, etc. If you are, you have now been doing online during 2 years. You've been sitting in front of your favorite computer at home doing stuff. Now you are going to go to a conference. So you're grabbing your laptop that you normally use when you're at conferences. Make sure that the laptop works. So one day before I left for SQL Bits, I said, maybe I should check that my laptop works. Guess what? It didn't. So I had to grab my work machine, which has a lot of security stuff on it, and it's a hassle to doing things. So yeah, just a friendly advice. Right, cool. Anyway, yeah. So we are getting more and more data. We want to do real-time analysis. Azure Data Explorer is Microsoft's big data analytics platform, and KQL, Custom Query Language, is the language for Azure Data Explorer. Cool, that's it. Questions? Yes, sir? Wait, I'm coming to you.
Can we create views, for example, through the Power BI for a direct query? And will it be faster than the serverless SQL pool?
Will what? Oh, sorry. Will what be faster than?
I mean, can we create views here for a Power BI direct query? This is like the first question.
So can I create views for Power BI? Yes, you can.
And direct query that in the real time I can use them.
Yes.
Okay. And will it be faster to the serverless SQL pool in the Synapse?
Will this be faster than the? So if you're not talking, if you're comparing this to not Synapse data, Synapse Explorer, but the normal SQL serverless pool, well, this is the common answer to any questions around computing. It depends, right? So if you have 2 billion rows and you want to do a Power BI to see something that lends itself in Azure Data Explorer, then Azure Data Explorer or Synapse Explorer beats the crap out of a serverless SQL pool, absolutely. Because it's a little bit like comparing apples and oranges. It's two different things. Is the serverless SQL pool faster in other circumstances? Absolutely, absolutely. Other questions? Wait, come on.
Seems similar to Spark. Can you sort of compare and contrast Spark to Azure Data Explorer?
Is this similar to Spark? No. Can you do somewhat the same things in the Data Explorer that you can do in Spark? Yes. Can you do more things in Spark than you can do in Data Explorer? Yes. Can you do more things in Data Explorer than you can do in Spark? Yes. They have. How's that for a non-answer? They are two different animals. There is, we have Spark connectors. So Spark can read from Data Explorer, and Spark can write to Data Explorer. Right. But it's two kind of different use cases. Don't forget, this is a, bless you, this is persisting of data. Whereas in Spark, you are, well, processing data all the time, kind of. Other questions? Yep, I'm coming. I owe you a notebook, by the way. So.
What do we pay for here? What do we pay for in the Data Explorer? Do we pay like for the time that it's used, for the VMs?
So what do I pay for in Data Explorer? Well, I don't pay anything because I have a sponsored account. No, it's a good question. So you're paying for compute and you're paying for storage. It is, however, people are telling me, and I tend to not look at the price tag. People are telling me that it is an attractive price for Data Explorer to do, to have data in Data Explorer. But you're paying both for compute as well as storage. Other questions? Right, so if not, please don't forget the feedback. Link, QR code, off you go. Thank you.